A mass spectrometer tells you which isotopes are in your sample. They get sorted from lightest to heaviest, and you get a graph like this, or at least the ones we'll see will be simple ones like this. We can see that there's 3 different peaks. Each of those peaks represent different isotopes. So one has a mass of 24, 25, and 26. The height of the peak represents how abundant it is. So this element has isotope 24 being the most abundant. To calculate the average atomic mass, which is what's found on the periodic table, it's a weighted average of all of an element's isotopes. So your formula can be mass of isotope 1 times its percent, plus mass of isotope 2 times its percent, and so on. So mass of isotope 3 times its percent, however many isotopes you have, and then divide by 100 at the end. Or you can also divide your percents at the beginning and get decimal forms. But your final average atomic mass has to be between the smallest mass and the largest mass because it's a weighted average. So our practice problem, we have 3 isotopes of UUS. We have 3 masses, and they give us a rounded mass. When they give you a rounded mass and a more specific mass, always use the more specific mass. So the first mass is 283.4 times its percent, which was 34.6. We're going to add that to the next isotope, which is 284.7 times its percent of 21.2, plus the product of the next isotope's mass times its percent. Make sure, again, that you divide by 100 at the end, otherwise you're going to get a large average mass that's not between 283 and 287. In this case, after you divide, you get 285.6. The unit is AMU, atomic mass unit. Go ahead and pause the video and try this one on your own. Restart when you have your answer. So this problem only has 2 isotopes. So you should have had the first isotope's mass, 64, times its percent, plus the other isotope, 55, times its percent. Then dividing by 100, we get 56.8 AMU, or C. The other type of average atomic mass problem that you'll see is graphs. Some graph problems are easier than others, but you're going to solve them the same way. Just like before, it's the mass of your isotopes. So on the bottom is our masses. We have a mass of 80, 82, and 84. For our percent, we would say 40 plus 40 plus 20 is 100. So for my first one, I have the mass, which is 80, times its percent, which is 40 over 100. So there's 40 divided by 100 of them all together. Plus, my next isotope is 82. It also has 40 out of every 100. Again, I'm getting the 100 by saying 40 plus 40 plus 20. And I have one more isotope, which has a mass of 84, and it has 20 out of 100. When doing the graph problems like this, we will not divide by 100 at the end because we're dividing by the total number of particles. When I'm done, I get 81.6 AMU. Always double check, is it between 80 and 84, which it is. So my answer is good. Go ahead and pause the video, try this one on your own, restart when you have an answer. So the first thing you should have done is added up how many particles you have all together. So we had 18, 14, and 25, which gave us 57 altogether. The first isotope mass is between 85 and 87, so 86. So we had 86 as our mass times 18 over 57. Plus, our next isotope has a mass of 89, but there's only 14 of it. But there's still 57 total atoms, or particles. And finally, the last mass is 92, and there's 25 of it. So plugging that into the calculator, you get 89.4 AMU. Go ahead and pause the video and try this last one on your own. Restart when you've got an answer. So just like before, you should have added 2 particles plus 3 particles plus 5 particles. If we look on the y-axis, we can see that we were adding these numbers on the y, not the 291.2 like we did in the previous problem, because we couldn't tell exactly what the mass was in this problem. That's why they were giving it to you on the top. While the previous problem, there's no way that this mass was 18, but the number of particles was left blank, so they were telling you the number of particles. So your first mass was 291.2, and you had 2 of them for every 10 particles. Your next mass was 292, and there was 3 of them for every 10. And the last one was 293.2, and there was 5 of those for every 10 particles. Remember, your answer has to be between 291.2 and 293.2, this being the most abundant, so our answer should be closest to that one, which it is. Our average atomic mass is 292.5 AMU. Some problems will just give you a graph and say which element do you expect this to be. So looking at the graph, I would look on the periodic table and find an element that has a mass between 291 and 293. Anything that had a mass outside that range, I know couldn't be the answer.